Okay, here we are finishing up 4A on your syllabus. We have 4 parts which are associated with 4A on your syllabus. Then we're going to do 2 segments to complete 4B, 2 segments to complete 4C, and D is just one segment to complete that. E, 2 segments. So that all adds up to 11, and this is number 4. Let's see, what have we accomplished so far? Looked at the sine and cosine functions graphically. We have been relating the function and the graph by shape. The sinusoid, we talked about that already. Amplitude, period. We're going to spend more time in section B, talking about its position on the coordinate plane. We'll spend a little bit of time on that here. Create trig models. That we're going to do later on in our discussion of this unit. Shifting vertically. You know this back from algebra. We have in front of us here the parent graph of, oh no, the parent, let's see if I can draw a parabola. Okay, it's sort of not that great, is it? But anyway, a parabola. This is the parent graph of a quadratic function. This is how it graphs with its vertex at 0, 0. That's important. When we talk about transforming, shifting vertically or shifting horizontally, we're going to key in on certain points. With a parabola, it will be the vertex. All right. Here is the general formula. Y minus k, where k is the y-coordinate of your vertex, but we always want to solve for y, so in the case of the vertical translation, instead of leaving the minus k on this side, we add k to both sides. So k is the vertical translation. Let's try, I don't know, what would you like to try? Y equals x squared. Let's try moving that. Suppose we decided to put it here. I'm going to try drawing that parabola as well. Oh, yikes, so bad. What is my k in this case? Well, we can look at the vertex and we see that this is a 2 by 2 grid, down 2, 4, 6. So it's plus a negative 6, or how would we write that? So our k in this case is, if we're looking at the vertex and just the y-coordinate, it's minus 6 right here. Okay? Shifting vertically, we're going to do it in trig, and the way that happens is we have this vertical translation. So if I, oops, can I grab this thing? Yes. Suppose I put it right, oh, I don't know, how about right here? Now maybe I should draw the sinusoid here, just to make it a little more obvious. So it looks exactly like the parent graph, except for one thing. And that one thing is that let me draw in. Where is my central axis on this one? It's right here. Don't usually draw this in, but I'm doing that right now just so we'll focus in on where the central axis is. Central axis is right here, and how far has it dropped? It was up here for our parent graph, right on the x-axis. That was the central axis of the sinusoid. So this is going to be now called y equals sine x plus, let me see, this is a -1, this is a -2, so plus a -2. What vertical shift could be used to move the sine position, the sine wave, into a position that would make its maximum value equal 0? Let's think about that. How would we do that? Make its maximum value equal 0. Where I place this green one, its maximum value is -1. So if it had been located, see how well I can draw it. Right up there, I would have had a maximum value of 0. So what vertical shift would I need for that? This would be y equals sine x minus 1. That would do it. Agreed? Let's describe how the graph of the following will differ from the parent graph. Now the parent graph for cosine, what does that look like? Let's just take a moment to draw it. The parent. If this is 2 pi, and this is 1, -1, and -2 pi. My parent would, let's do our 5 critical points. This, remember, we're doing the parent. Okay, I'd have this point here. At pi, I'd have a -1, and at 2 pi, I'd be back to a +1. And midway between, I would have an x-intercept. Over here, same thing, -2 pi is at 1, -pi is at -1, and midway between is a y-intercept. So using my 5 critical points and then reproducing them, I get something. Oh, it's so sloppy. I'm so sorry about that. I should be using graph paper. Now, what's happened with this one? I've just dropped the whole thing 2 units, haven't I? So let me get a blue. And I know now that if I drop this whole thing 2 units, I'm going to be peaking at -1. That's going to be my high point. Oh. And my low point is going to be at -3. Put it down here. And midway will be at -2. I'm sort of freehanding it, and it's not looking all that good, is it? So how would this graph differ? Well, I haven't taken this into account yet, have I? Ooh, so I better do that. Just a moment. I'm going to change the color on this. I think I will change it to purple. Oh, didn't work. Try it again. I'll do it here, where you can see what I'm doing. I'm going to change that to purple. And maybe go to smaller. Okay, that's better. All right. So this isn't quite it yet, is it? What I need is to reflect it, right? Which means my high point's going to become my low point. My high point's going to become my low point. It'll cross at the same place, and then so this is reflecting it. All right, so here we go. I've got a graph that looks like this. Now, probably be a good idea for you to do this on your calculator so you can see just how it all works. I'm going to group those together. And then shrink it so that we can still see the next problem. Okay? It actually works better because now I can just circle that 2, because when I started out here, all I did with the purple was drop it 2 units. All right, what about tangent? What does the parent graph of tangent look like? Let's draw a sketch. We've got 2 pi here, negative 2 pi here. We've got 1 here and -1 here. That's enough, isn't it, for us to kind of get the idea of that. First off, we're going to just look at what the graph of tangent looks like. What does that look like? Well, we've got a lot of asymptotes, don't we? Here's pi. Here's -pi. And we're going to draw in our asymptotes. Let's see if I can do it. They're going to occur right here and here and here. This is where x becomes 0 in the unit circle at 0 right here, an angle of 0, y is 0 and x is 1. So for I think I have to change back. No, maybe not. Y is equal to 0, x is equal to 1 at 0 degrees, so the tangent of 0 equals y over 1, which is fine. But when it gets up here, this point is 0, 1, and that's not fine, because when x goes to 0, what happens? Yes, at 90 degrees we have an asymptote. So let's just quickly sketch in what the parent graph of tangent looks like. It goes from -infinity on up All right, so that's what the parent looks like. What happens if I shift all of this up 1? What's that going to look like? Fortunately, it's positive, so I don't have to worry about any reflection here. Well, now the asymptotes aren't going to change, but where this crosses is going to change. It's going to be at 1. So, boy, it is helpful to use colored pens, isn't it? All right. Going up like this and down like not like that, but oh well, you get the idea, I think. All right, so it just shifted the whole thing up 1. Now you didn't actually have to draw that. You could have just written it out in words. On your calculators, I'm going to want you to do this work right now. Got plenty of time to do it. Graph the following curves in degree mode. So think about what your window needs to be. Let's go in degrees. So put your calculator into degree mode and go from 0 for x min to 360 for x max. Make x scale, let's see, 18 degrees is what it looks like here, just to match the diagram in your book. Y min would be -3, Y max positive 3. Y scale looks like it's 0.5, and resolution will be 1. You have your parent right here. Then what's this one do? This one is adding 2, so it shifts it up 2. And this one is subtracting 1, so it shifts the parent down 1. This is the one we just looked at where this shifted the range in such a way that the maximum is now at 0 and the minimum is at -2. A curve in this form, whether it's sine or cosine, will shift up or down based on this value. We define the vertical translation this way. If d is a positive number, it translates up d units. If d is a negative number, it translates down d units. And if d equals 0, in other words, you don't see, like up here, there's no d, you have no translation. So go ahead and work with your calculator, and I'll see you back in class.